Uh, Good evening, everyone, for joining live, and greetings if you are watching this recording later on demand. I hope you and everyone in your family is staying safe and healthy. As Matt said, I'm your first speaker for the day. Today, I'm going to talk about Azure Static Web Apps, which is a recently launched Azure service to host static applications. Do note that the service is currently available in public preview, and I will not recommend to use it for production workloads unless it becomes GA or generally available. Uh, Quick introduction about me. I think Matt did a great job on that. I work for Kivit as a cloud architect, and I have been awarded a Microsoft MVP award recently. I'm a Microsoft certified trainer, and I hold a few other certifications as well. I run Omaha Azure user group here in the city, and I do blog on webagujral.com. You can follow me on Twitter or connect with me over LinkedIn. With that, let's see what we are gonna talk today. Today we have a very short agenda as it's a 15 minute talk. Azure Static Web Apps is an Azure service which is currently in preview, and I have played around with it probably for an hour or so before this presentation. So in this presentation, I will just share my first thoughts and some of the things that I liked about static web apps. Let's start with it. So what Azure Static Web Apps are, ASWA as I am calling them. ASWA is an Azure service that automatically builds and deploys full stack web applications to Azure from a GitHub repo. When you create an Azure Static Web App resource in Azure portal, it automatically sets up a GitHub Actions workflow in the application source code repo in GitHub that continuously monitors the branch that you have selected. And every time you push commits or accept any pull request into that branch, the GitHub action workflow automatically builds and deploys your app and its API to Azure. Uh, Overall, there are two pieces to Azure Static Web Apps. One is, since they are static apps, it includes the static content, which is served through geographically distributed locations. I didn't find any information how it is, but my understanding is it's based on CDN or Content Delivery Network in Azure. And the second piece to is an API endpoint, which is implemented using Azure Functions. Azure Static Web Apps support popular libraries and frameworks like Angular, React, Vue, and Blazor. You can also utilize Azure Static Web Apps to host your sites built on top of site generators like Gatsby, Hugo, and ViewPress. Here's a workflow for an Azure Static Web App where you have a GitHub repo towards the left. When you create an Azure Static Web App in Azure, it creates GitHub Actions workflow in the app source code repo. GitHub Action monitors the linked branch in the repo whenever there is a pull request completed. GitHub Action automatically builds and deploys your app as well as the API to the Azure Static App. A few things that I have learned about Azure Static Web Apps. The first one being routes.json, through which you can define your routes for your static web apps as an array of rules. You have to place your routes.json as in the root of the build artifact directory. Routes in static web apps lets you define basically two things: backend routing rules and authorization roles. The rules are executed in the sequence as they appear in the array. Roles are defined in routes.json, and users are associated to roles through invitations. And when speaking of invitations, you can use invitations to associate users with roles and authorize users to routes based on the rules defined in the routes.json. Static web apps supports few identity providers today, including Azure Active Directory, GitHub, Facebook, Google, and Twitter. It supports two built-in roles, anonymous and authenticated. And obviously we can define our own custom roles in routes.json. As I mentioned earlier, Azure Static Web Apps provide serverless API endpoints via Azure Functions. If you have used Azure Functions in the past, do be aware of the limitations that they have For the API endpoints in static web apps, the API route prefix must be API, and you cannot use any other API route prefix. You can use JavaScript, C# or Python based APIs in Azure Functions, and not any other supported language like PowerShell or any other. Currently, if you are defining route rules for API functions, it only supports redirects 301 and 302, and also it supports securing your routes with those roles that we will see shortly. Uh, do note that since it's an API endpoint, so your Azure function can only support HTTP trigger within an Azure static web app and no other trigger. And the only way to see logs out of your application or through your API endpoint is if you integrate it with the application insights. Another cool feature I've seen in ASWA is the pre-production environments, which provide a full-fledged staging environment. What happens is when a pull request is created against a branch that the actions workflow is watching, a pre-production environment is built where you can test your changes before pushing your changes to production. And once your pull request is approved and merged into your branch, the changes are merged to the production environment in Azure. Microsoft documentation says that multiple pre-production environments can coexist at a time, but since the service is currently in preview, it only supports one staging environment. Be aware of the fact that staged versions of your application are currently accessible publicly by their URL, even if your GitHub repo is private. So that's pretty much what I have learned about Azure static apps so far. Let's jump onto a quick demo. So here I have a Blazor app set up on my machine. What I have is an API here, which is of Azure function, and I have a Blazor app here, which is my client app. If I show it to you running here, you will see how it runs. Here's my Azure function, which is getting started. And here's my client app, which has shown up. So my function app is running on this endpoint since it's an HTTP trigger based function. Here's the endpoint for that, and here's my Blazor app. It has a couple of pages in it. This is a static counter, and this is a weather forecast page. And this data, what you are seeing here on screen, is being fetched from that Azure function. You can go ahead and see the. I will share the link for this GitHub repo. I have utilized the samples published by Microsoft, though. You can fetch it from there as well. But here is the fetch data Blazor page for that particular page where I was showing the weather forecast data. And here's the code for my Azure functions where it is returning the JSON that I'm displaying. I already have pushed it in my GitHub repo, the same piece of code. And I already have created a static web app. I'll show you how to create a new one shortly, but this is a static web app which is running in Azure. And this is the same app that I was showing you earlier running locally, now runs in Azure. It's not showing demo gods. There you go, it came up. And let me go show you how we can create a new static web app. If we'll go to the create new resource and look for static web app, which is certainly in preview today, we'll click on create. Do note that it is currently available only as a free tier, and there is no cost for that, but that can change once it goes GA. You have to choose your subscription, choose a resource group. I already have a resource group created for this demo. I can give it a name. I can opt for a region, and then you will see it asks for my GitHub credentials. It will connect it to my GitHub account, it will show the organizations that I have. I have a single organization. It will automatically fetch different repos that I have. I will go ahead and pick up a different one from the one which I have already set up before. I don't have any branch, but if I go ahead and let's say pick the demo which I have already set up before, it will give the name of the branch. And once you will choose the branch and click on review plus create, it will go ahead and create your static web app probably within a few seconds. And the moment you will click on create, it will go ahead and provision the workflow, the action workflow here. If you will go ahead and look into the action workflow, I have pushed this code once. And this is all auto created by Microsoft for me when I provisioned Azure Static Web App in Azure. And here is the task that it has performed. It has built my code and deployed it to Azure in my static web app. Here's the link to the site where it has deployed. It points to the same site here. And here's the URL for that. As I was saying, here's the function app that got created. Oops. Here's the weather forecast function that got created as my API. But it's slightly different from the normal Azure functions that you will create in Azure portal. I can't really go and see it's integrated within the static web app. Here are the environments. If I have multiple developers working in my team, or if there are multiple pull requests, every time a pull request is created, it will automatically provision a self-sustained staging environment for me here. And once I approve my pull request, it will automatically go ahead and push the changes to the production environment. You can assign your own custom domain to your app. That's pretty much that is available today as of the Azure Static Web Apps. Here are my overall thoughts after playing with this service for an hour or two. That it provides a very easy option to deploy your static apps from GitHub. Cool feature is when it automatically sets up your GitHub action workflow to deploy your code directly from GitHub repo. You don't have to do anything. Secondly, it does supports many popular frameworks like Angular, Vue, and others. I was really impressed with the integration with the Azure functions, though it still has some limitations because it is in preview, but I think it's very powerful. It is still in preview, so I will not recommend it for production workloads. One limitation I've seen is what I'm not impressed is that pricing is not clear yet, and it only offers free tier currently. So I'm not sure how it is going to roll out once it's GA, how the pricing will look like. Lastly, the environments looks very promising to me. Here are some of the links that you can refer for further reading. The links to Azure Static Web Apps documentation, link to GitHub Actions I have listed there. If you don't know what Blazor is, head out to that link. Blazor is a new framework for running your C# based code at client side, and then Blazor and C# API support for Azure Static Web Apps is actually being announced this week. So do go ahead and check it out. The link I have provided there, I have used the same demo, same sample for my demo. And the GitHub repo, the one which I have used, if you want to run it at your end, you can go ahead and download the code at your machine and use in your own GitHub repo. It's a public repo. And with that, that's pretty much I had for me. Matt, over to you. I will be available on the for whole meeting. So if anyone has any questions, feel free to post it on the chat and I'll be happy to answer them.
Yep, great, Vaibhav. Thanks so much. I'm going to move right through it because we're going to run up against our clock if we don't get going. So Marcus is up next, who's going to talk to us about some of the work he's been doing with virtual hard drives. Marcus has been a long speaker for the user group several times in the past. So if you guys, you'll know who he is. So Marcus, the floor is yours.
I broke my chair. So yeah, I'll try and make this quick. It's very interesting, but one of the things that I've run up against, especially as a contractor, or even generally just trying to keep my work separated from from my personal life and my fun programming has been organization. And as you can see, I've got several hard drives in here, and 1, 2, 3, 4, 5, 6 hard drives are real, but one is not. One is a virtual hard drive.
Hey Marcus, are you showing us something?
Yep.
I don't see it.
Because I forgot to click on my screen. Sorry about that.
All right. It happens.
Yeah, thank you. Like I said, I'm trying to move fast. So as you can see, I have 6 hard drives that are real. One is a removable hard drive, or SD card, and then one is not real. So I have a lot of data that I play with from day to day: video games, development stuff, and backups and that sort of thing. But as you can see, I have a lot of hard drives here, a lot of things attached. But what's really interesting is I also have a bunch of virtual hard disks. So if you notice this little blue icon, this represents a virtual hard disk that's attached to your system via the virtual hard disk management system that's built into Windows 10. It basically treats that data stream differently than other hard disks, but I digress. So I have here's that OneDrive that you saw on my PC. That's my Windows Store app. I've offloaded my Windows Store installation folder to this virtual hard drive, and I also have several other ones here that are mounted to specific hard drive locations, and I'll show you what that really means via a couple diagrams. The first thing to note is I have my main hard drive is 464 gigabytes worth of space. The largest piece being, my user folder. But if you look up here, it says that I have 1.2 terabytes allocated to my C drive, just to my C drive alone. And what this represents is my using symbolic links and other methods to mount virtual hard drives into the space that's allotted. My user folder says that it has one terabyte worth of space, but only on this particular hard drive, it's only allocating 193 gigs. All right, so I kind of giving you a really neat, hey, that's weird. How did you do that? So the way that I ended up doing that is I am working on a project that allows you to create a list of virtual hard drives or locations that you would like to offset, or I tried to coin it as installation displacement. Basically, you're using a virtual hard drive to store the data someplace else on a different hard drive. The idea came from hey, I wanted to be able to install every one of my Steam games on my PC, but I needed that performance of that SSD drive, right? So how can I get, sorry, I heard a beep. Is that somebody coming in? Or?
That was somebody coming in.
Oh, sorry about that. I get distracted like a squirrel today. So I wanted that performance of the SSD drive, but what I ended up doing was like I'd have to uninstall, reinstall, uninstall. Took a ton of time, ton of bandwidth, and I got really tired of it really quick. So I found out that, hey, this was about 2010, 2011, right when VMs were kind of taken off with regards to availability to the home user, and back when VMware's workstation actually was within financial reach for me. And So I started playing with virtual hard drives and all that great stuff. What's really cool about this is that if you come in, the way to do this simply is if you go into your disk management, you have the ability to create a virtual hard drive and mount it directly from this particular management console. And I'm just gonna make a temp one here, show you how to do it. I can, another cool thing is like I can make this a 40 terabyte hard drive as long as I select VHDX. The difference between these two is this is a very old version of the virtual hard drive. This is a very new version. And of course, it warns you it doesn't work on anything older than Windows 8, meaning you can't mount it or even maintain it on anything older than Windows 8. But I can create this hard drive and call it 40 terabytes. So I'm going to do that. I've only done this one other time. I don't recommend doing this because I've had some stability issues with this kind of thing. But at this point, Windows treats this just like any other hard drive. And you basically initialize your disk, you pick your boot record or your partition table record type, and then you format your hard drive. I'm just going to click through this really quick. It's going to quick format it, and there, all of a sudden, I have a drive called H that is 40 terabytes worth. Now, granted, that's limited by where it's being stored, and currently it's being stored on O, which has only got 373 gigs left on it. So if I tried to fill that up with more than what's available, it will start throwing errors. It'll just basically won't write to it. It's like a full disk at that point. So if you do make a very large disk, keep that in mind. It's limited by the space available on the drive that it's currently stored in. So let's look at how this actually works, right? How am I doing this? So for mounting a hard drive other than a letter drive, what we're doing is we're using symbolic linking and junctions to have a virtual hard disk stored on a secondary drive, but that disk's space is actually allocated to a folder wherever you tell it to be mounted at. That's the symbolic link. The link between that drive's content or that folder's content is how it's being considered, and the location where you've got that mounted, where that reference point is. So I can technically take any application from the programs files within reason. There are some applications that are not movable, like you can't move the Windows folder. I tried to make a profile in the users folder. So like that's one that I can't move. So if you go to here, let me bring this over here. So these folders in here cannot be moved. Folders under them can be moved, except for the registry stuff. All this registry stuff, the fluff that you see for the registry, can't be moved. It's a security issue. We can all guess why it won't let you do it, but I haven't figured out how to trick Windows into letting me do that. It is one thing that they did for their IoT. They tricked Windows to allow you to have these registry files someplace else, but I haven't figured out the magic sauce in that. So another thing that I've done is that I've been working on is what I've been calling virtual hard disk inception. The concept is I want to be able to take a Visual Studio installation, like Visual Studio 2019. I want to take that installation that installs to several folders on one drive, but I wanted to store it on one virtual hard disk. And the way that I've done that is I've kind of said, okay, well, I'm going to have a parent virtual hard disk that is going to store other virtual hard disks and then use those to mount the application to the, let's say, the programs folder application, and then any subsequent folder that may need to be referenced or stored for function later. And this, it's a compound virtual hard disk, or kind of basically storing related files together. Now, what's really cool is that I've got scripts on how to do this, how to make it work in PowerShell that, oh, here, let me go here. This is a little bit more easier to understand. That basically allows you to take a list. Let me show you that list, which was on the web page. That's why I went there first. It takes this entire list of, where did it go? Maybe I was wrong. Oh, here it is. It takes this list of drives. This is how many drives I have that I've been using to mount. One of the most annoying things for me, especially as of late, is email. Microsoft Outlook takes up gigabytes of hard drive space, and you can't move this folder. It just doesn't let you move the folder. So what I ended up doing is I made a virtual hard disk and essentially didn't move the folder. I just moved the contents of that folder. So now I've offloaded this to my D drive. So I've saved, what, 30 gigs? Well, I've saved a lot of space over time. And I've offset it off of my primary hard drive. Another thing that this does is that at startup, there's a scheduled task in here, and if you run this, if you use this, what it does is it allows you to do things like this Windows storage. It allows you to mount this at startup. So if this wasn't mounted at startup, Windows would have problems and start crying and telling me, things are broken and that sort of stuff. Anyway, that's how I've dealt with that. If you guys are interested, you can find all of this scripts and all of this information on my GitHub. I have a lot of repos, but if you're looking for this particular one, VHDX to folders is the project. It's not complete, but what I'm working on is making this I'm in the script, you're going to run a function that says take this folder, take the contents of that folder, migrate it to a VHD, and mount that VHD in place of that folder to automate the process that I go through. Because it takes, transfer of data from one disk to the other, and then if you're dealing with gigs, it could be several minutes to like a video game that's 90 meg, I think or 90 gig is the largest game I've had. It takes about an hour to transfer all that data. So scripting it and allowing it to do it on its own has been the goal of this project. It's let me take my entire workload and say, okay, I don't want to work on anything. I don't want to have to even see programs or software that I have to develop for work on my machine until I need it. So I'll go and remove those disks or eject the disks. Oh, here, let's do it the right way, not the wrong way. Well, the right way is basically to right click, eject the disk here, and it'll disappear. No, it's no longer available. It still shows up here. I think that's a bug, but the drive is gone. well, it's not gone. It's just not mounted anymore. As for space, as long as you're using the differencing process, that 40 terabyte hard drive is still only taking up a couple 100 megs by default with nothing on it, and that's basically just reference data. But here's my Windows app storage. It's 100 gigs big, and it's storing all of my Windows Store apps. So if you guys have any questions or thoughts, I'm happy to answer any of them. If you are interested in this, feel free to reach out. I will be doing a couple YouTube videos to dive more into depth on how this works, the complex drive and the simple drive mounting works, as well as to explain the scripts that I've written. So.
Great. Thank you, Marcus.
Mm-hmm. Hopefully that was quick, simple, and easy.
Yeah. Clearly has some passion around data.
It's just management, right?
Yep.
Was the bane of every computer person is management of data.
Great. Thanks again, Marcus. We're going to move right along to Rob Kraft, who is actually from Kansas City, but he's joining us tonight and is going to tell us about SQL injection. So I will turn it over to you, Rob.
All right. All right, I think I'm sharing my screen now. I'm actually assuming that all of you are familiar with SQL injection and what that is. I'm going to go over a little bit of code to help your applications identify SQL injection risks. So as Matt mentioned, I live in the Kansas City metro area. I do a number of talks on SQL injection from the DBA administrator perspective and the SQL developer's perspective, the hacker's perspective, and the application developer's perspective. And I usually have a whiteboard. I'm standing in front of people, and I usually write up there that I'm from Lee Summit, Missouri. And then I go over there later and I add the little apostrophe to Lee Summit because there is actually an apostrophe in our city name. And early on the early days of the internet, I went to so many sites where I'd enter my city because I was going to order something, and the site would give me an error message that let me know right away it was vulnerable to SQL injection. So I've always been interested in it, and honestly, part of it is because I live in Lee Summit and I've had to deal with it on so many websites. So what I've got is pretty simple. I think pretty simple compared to the last presentation. I have a blog post. I'll share this URL probably in your Slack group. It just kind of explains what I've done. But the scenario I've faced a couple of times is I've come into an existing fairly large project, .NET project that has a lot of SQL statements coded throughout, and somebody wants to know if we have any risk of SQL injection on any of those SQL statements. And of course, one approach you can take is you can just have people sit down and review all of the statements one by one. It takes a long time. And of course, the big problem is after you've reviewed it all, then you start coding again. A year later, you may have introduced new SQL injection risks, and you might have to go back and review it again. So what I want to do is add something to the code to do some SQL injection detection in the code. And I want to point out that you can do this pretty easily to an existing code base. So the two things I want you to take away from this short presentation is number one, that you can use something like the decorator pattern to implement your own code and override the code that Microsoft provides for running SQL queries, basically. And then number two, just this little framework itself and some techniques within it to try to identify SQL injection risks. Now, I'm not going to claim this will catch every case of SQL injection. I will never make that claim, but I think it's done a pretty good job of catching most any possible way of injecting data using SQL injection. So let's just I'll jump over here to the code. So really, there's not a lot of code here. It's a SQL extensions class. My blog post links to my GitHub repo that has this code in it, but it's just a few hundred lines of code. There's some formatters. It's fairly verbose code, but really what it's doing is pretty simple. First of all, I have extension methods to override each type of SQL command that we're generally running, particularly using ADO.NET. Now, my example's focused on SQL Server, but you can certainly use this technique on any database platform. Some of the SQL injection testing, the code you write to test for SQL injection risks can change a little bit. But like I said, this code, you can grab it and you can modify it yourself. It's not, I wouldn't expect you to deploy this DLL. I would expect you to grab this code as a starting point and then modify it on your own. So basically, we write our own extension method, and everywhere that's in our code where we currently call execute reader, we're going to replace it with execute safe reader. So the way I recommend implementing something like this is basically you go through your entire code base and you replace the Microsoft default command, execute reader or execute non-query, and you replace it with your own override that does nothing different. But the only thing we're doing here is then we can scan the code later, or maybe you can add some static code analysis to your build process to say, hey, we want to make sure none of the code is using this exact method anywhere. None of it uses execute reader, because we want to make sure all of our code goes through our execute safe reader, which is doing our extra stuff. So that's tip number one, I should say, not a trick really. That way, because it's very important that you be able to, on a regular basis, make sure your code minimizes the risk of injection. So the other piece of this, once you've done that, then you can slowly add in different code, and that code will apply to your whole code base. At least in this case, everything that was formerly calling execute reader that's now calling execute safe reader. So I'm not doing this for stored procedures, which, as a lot of you may be aware, it's generally preferable to use stored procedures to minimize the risk of SQL injection. I will point out that in case you're not familiar with it, using stored procedures does not eliminate the risk of SQL injection, because you could be building your SQL dynamically inside of your stored procedure. In that case, you are reintroducing SQL injection risks when it gets executed inside of the stored procedure. But for the purposes of the apps that I have worked on, our stored procedures have been fairly simple and they don't have dynamic SQL in them. Well, actually a few of them do, but we have careful reviews around each of those stored procedures that have dynamic SQL in them for every release. So anyway, I'm focused on the non-stored procedure SQL statements, and this code is just going to pull the command text out, and then we're going to do this validate SQL. And if we find a SQL injection risk, something we don't trust, we're going to throw an exception. So once again, this code, it's a little bit left for you to decide what you want to do if there's an exception. It's even up to you to decide if you want to throw an exception or not, how you want to handle that. But this is set up to throw an exception if it thinks there's a SQL injection risk. So the things that the code actually does to try to decide if there's a SQL injection risk within the SQL that's passed in is we check for illegal values using regex. So the first check is an ASCII regex. And I'll scroll down here somewhere and show you. This is designed to be loaded from a configuration file. We did this because we deployed our code to many different clients, and some of them occasionally had something different and we needed to change our detection algorithm. So we made it a little bit flexible so it could be loaded. So this first one, it's just doing a check to make sure that the ASCII value of each character of the SQL statement is between 1 and 255. So if it's ASCII value, if any of you are familiar with SQL injection, there's like a Unicode value of 0 plus, well, comment there, 0, 02 BC. This is a known, I should say, Unicode value that can be used to cause SQL injection. Yeah.
Hey, Rob, we're
Yeah.
seeing the web browser. I don't know if you're just sharing that window.
Oh, I'm sorry. I must not be sharing this screen.
Yeah, I think you just probably need to, you might have to stop sharing and then reshare the screen.
Yeah, I'm sorry about that, everyone.
Sorry, should have let you know sooner. I didn't realize it until just now.
Happens to the best of us.
And it happens to me too. Okay, screen 1. That's. Well, I'm going to share the code. Okay, I think you see my code window now.
Yes. Yep.
So sorry about that, guys. I'm going to back up just a little bit real quick here and just show you. Here's what I was talking about with this is my extension method. It's overriding the execute reader. Like I said, when you first want to implement this, the way I would do it, I'd go through my entire code base and just replace execute safe reader or execute reader with execute safe reader. And that way I'm telling all the code to now run through this method. And of course, initially this method doesn't do anything different than the method did before. But then we're going to add our logic here, I think, to do the SQL injection testing, validating the SQL. So that's what I was starting to go over. So I've got 3 tests, and one of them is a registry. Most of them are regexes. So this first test is going to make sure that all the ASCII values of all the letters that make up the select statement or the SQL are between 1 and 255. And that's because one of the typical hacking approaches is to use some non-ASCII values like Unicode 02 BC, which will also get treated, well, it used to get treated by SQL Server as a single quote. I think in SQL Server 2012, it changed so that that no longer gets treated as a single quote. So it's a little safer these days. But this may be something that your app doesn't allow, because if you are running code in foreign countries and you need to support Unicode characters, then this approach wouldn't work for you. But you could modify this regex perhaps to allow a wider range of characters, but not all characters. But the apps I've been working on, I guess I've been fortunate. They've been running in the United States. They just have to deal with American English, and we've been able to limit them to ASCII values 1 to 255. So that's the first test that this little block of code will run. It'll check to make sure that the ASCII values are within the range we expect. Then the next step is we take the SQL that's coming in. So it might be a select statement like this. And we want to strip out anything that's inside of quotes or anything that's in a comment. Because what we're ultimately looking for is something the hacker is attempting to do with some command to a SQL server, like to issue a delete or a drop table statement to the database. So if a user comment just has the word delete in it, we don't want to reject that SQL. So this bit of code is going to say, okay, find everything that's correctly enclosed inside of quotes and just delete it out of the SQL. Now this is only for evaluation purposes, which is why I'm returning new SQL. Once we have removed all of the stuff that's commented out or safely enclosed inside of quotes, we have some SQL remaining that looks like all command pieces of an SQL statement. We then do a check for illegal keywords. So we're running a select statement here. And if there's a select, there should not be a delete. There should not be a drop table. We actually have set up a list of words that we are looking for, and if we find these words, we will reject them. So if we see the word information schema, we're going to reject it. If we see insert, if we see update, if we see delete, we see truncate. I'm sure a lot of you are aware why we don't want to allow these words. XP command shell, those of you familiar with SQL Server will know we probably don't expect our end users to be providing XP command shell in our SQL statements. So that tells us there's a risk of SQL injection. I do want to scroll back to the front here. This particular regex says look for a space and then the keyword followed by a space. We also don't even allow a semicolon in ours, which means we can't send multiple statements to the SQL server. You may or may not want to do that. It depends on how you're writing your application, if you're allowing multiple SQL statements to be sent to SQL Server. The other thing, this is the one that we had some clients tell us, well, we use union statements. We gave them tools to build some SQL, and sometimes they would have union statements. So we'd have to change this to pattern so that it would not reject something that had a union statement in the SQL. But I tried to set up my sample code here so that it's fairly flexible, once again, so that you can take this code and modify it to work for your application. I also set up this flag to say, okay, well, if you find a comment in the SQL, do we want to reject the SQL? In most of our cases, we do, because we don't expect a comment to be part of the SQL. But you don't have to handle it that way if you are potentially expecting comments. If we are going to reject comments, we have to be able to identify the comments. And once again, this example is focused on Microsoft SQL Server. If I were checking for comments on some other database platform, I might need to have some different identifier to try to find out what a comment is. So that's about it in a nutshell. It's really kind of simple. Like I said, I think there's two things to be aware of. One is the decorator pattern, which is where we are going to add our own commands, and then we are going to use our own due diligence. Either what my company used to do is just at the end of every release, we would do a scan of the code to do a find all on .executeReader, make sure there was no instances of it other than what's inside of our override methods. Do the same thing for execute non-query. I would say do the same thing for like execute scalar, but what we did is we avoided using execute scalar. We rewrote those as execute readers just so we had less to maintain here. And the second thing is then do some validation of SQL. I also want to point out, once you have a framework like this in place that's wrapping all your SQL, you can do other things, like you can add some logging of all the SQL statements, which we had done. You can even edit the SQL on the fly. So another project I'm working on, we split data into two databases, both on the same SQL server, and instead of changing a lot of the existing code, we were able to use this technique to say, okay, well, when certain things come in, we will implement a using statement and redirect the query to connect to the other database. Just did like a use database 2 on those queries and point them at the other database. So that's all I had to go over.
Rob, there's one question in the chat.
Sure. Okay.
Ravi, he's asking about ORMs and whether or not this applied to ORMs, or if you're using an ORM, this is necessary.
Well, I don't know about necessary. Once again, I don't know about necessary. I would consider it, because I don't think anything is necessarily foolproof. Yeah. You know, most of the ORMs, you know, like if you're building link queries, there's not much risk, but most of them allow some little backdoor options where you can kind of construct some complicated SQL on your own. And those are the ones you need to be worried about. If you don't have many cases of that, then you're probably in good shape. And most of the ORMs use, let me show an example. Most of the ORMs use better syntax. So
Right.
This is the framework I have here is good for a select statement that looks kind of like this, where we do select whatever, like, and then we have this string we're building. So we're building the select statement on the fly. If you're starting out building an app, and I have this preferred example, this is kind of the way you want to write it. You want to do it like this, and you want to do like product name and use parameters. And when you use the parameters, SQL Server, the libraries in .NET for SQL Server are going to handle the SQL injection detection for you, so it's far less of a risk. So if I knew all of my code base is using parameters, then I wouldn't be so worried about it.
Yeah, which should be the case if you're using an ORM.
Yeah, exactly. An ORM is kind of the same thing. Yep.
Yep. Cool. All right. Well, I'm going to keep moving right along. Thanks so much, Rob.
You're welcome.
Your participation in our group tonight. Great. So next up is Srikanth. Srikanth, are you? Yeah, you're. Well, it says on my list that you're leaving. Hopefully, you're not leaving.
Or I
Hello.
can start.
Hello?
Oh, there it goes.
Oh, there he is.
Oh.
Yeah.
Hi, let me share
Yeah.
my screen.
Yeah, go ahead, Srikanth.
You guys see my screen?
Yep, I see it.
Okay. I'm not sure if it's duplicating. If you can see the one, oh, I think it's not projecting the
I see
actual.
the preview.
Okay, 1 second. Okay, I think now you guys should be good. Okay. So I think the topic today would be building a laboratory products, and we add some software development lifecycle changes. What are the things that we did in our company, and some of the highlights and challenges that we faced. So I will just quickly go and start. So about me, I'm working as a software dev lead at KDX, which is a biotechnology company, and been working building software systems for more than a decade. And I have my LinkedIn profile here, and then let's go. So today's agenda would be the software development lifecycle changes that we did and the architectural changes that we did for our products. I'm going to skip this. So basically, I will not go much in detail about this, but there are like multiple products that we have, and we are trying to build some core components. And we do have some digital software products that are provider support and patient support. So we are also having some machine learning and data management coming from the transplant data platform. So the background of this is who like basically the software teams and the disciplines that interact with the software teams. We are trying to change from a waterfall model to a agile-like development model. And what are we trying to do here to use some tools to support the regulated software development? As we are in a biotechnology company, we need to have those regulated software development processes established and use the processes to prioritize, plan, and execute technology and practices. This is what we are trying to do, and how we are going to achieve that using Azure DevOps. We choose Azure DevOps as our solution for this, and basically for requirement tracking or test traceability and the document generation, which will be automated from the Azure DevOps. And as I said, it's like an agile-like milestone-based development. It's not like a purely agile. It's something a mix and match of both, and automation and the artifact repositories and everything. Let's go to the next screen. So this is what we try to do. Basically, we'll start with the planning, development, and the testing, and verification and validation. But we do plan for a quarter, and there will be one planning sprint and a couple of dev sprints. This is kind of a fixes or things that we need to do, and again a couple of dev sprints and stabilize. And this is for one quarter, and it's not like a typical agile. Like every sprint, we don't have a planning. We do one-time planning. And let me go. So these are the market requirements. We do need to do the user requirements and software requirements. That's kind of needed. And the test cases are attached to the requirements and stuff stories. That way, it will, if there is any audit, we will get past the audits too. And that's one of the differences that I saw here. And this is the planning process, which we do plan ahead of the quarter, like for the first quarter, we plan for the second. And the tools that we are going to discuss here, earlier we used to do the planning like Word documents or Excel spreadsheets or a test, I think testing protocol. It's called basically all the test cases are attached here and the requirements are attached here. So what we're doing with Azure DevOps, we're moving everything to Azure DevOps and backlog grooming and whatever the planning phases are here. And development wise, we're structure sprint based and review strategy. And the builds, we used to do manual process, the local builds and push it to the softwares. Now we are doing automated builds, and the documentation will be generated from the Azure DevOps. Previously, we should do the manual revisions. These are the advantages of switching it to this process. What are the benefits? Predictability is one thing that we are doing. What it helps us to predetermine the planning process and the releases, basically in which release it goes, and it's coming from the other channels and the work being just coming to the developers. And the other one would be confidence. It would be like setting the expectations for the customers and presenting the organized things. The third one would be the transparency, where everyone will have the visibility into the process, and any triage effects will be clarified with that. So these are the activities. I think most of you guys are familiar with the product definitions and what are the software tasks was and what we have inside this. So I will skip this. And we do have the traceability matrices and the risk assessment that should be notified. In the initial planning phase, we do assess what are the risk assessments for that, and what if it doesn't go, if it goes wrong, or if it doesn't happen, those kind of things. And so here you can see this is like the milestone. Each milestone would be like this, which has the planning, future development for 2 sprints, and this is the edges. And again, so this is kind of a high level how the milestone process works. I have one example of how the software development life cycle, and we have some beta testing here, which is the before the release and the revisions in the release phase. We classify them as DRs, like DR1, DR2 till DR5. And the technology improvements, the DevOps background, continuous integration, work item tracking, we choose that, and the source code repositories, build and test automation, artifact storage and redistribution, because we have a lot of NuGet packages that we store and use it internally. And Azure test plans. So everything will be at one place instead of having in multiple places. That's one of the key factors to go to DevOps, so that you don't need to switch between multiple systems. This is kind of a high level how the feature branches and the develop branch, how it's basically it's architecture of the DevOps. And the project structure that we have is divided into this, the requirements and support and documentation. And it's kind of high level UI business logic and analysis data components. And coming to the technology side, we have few applications, few products basically, which are in C++ and VB. So there are kind of old 10 and 15 years old applications. So we are migrating them into C# and Entity Framework Core. And we're creating core components because all of the lab products uses the same, behind the scenes, it uses to an extent same business logic and same component, but there is a slight change between all of those. So we try to go with a structure base, like the architecture I'll show in a second here. So this, we have the UI automation framework, WPF layer, and these are all the install, like it's like a Windows applications. And we have the logic layer and the analysis and the persistence layer. So this would be the core components here, and every product will have its own database as well. Coming to the data persistence options, this is what we are doing now with the Entity Framework Core, and we choose a code first approach with that too, and we are able to make everything from the code base. And I think these are the table categories that how to base the role-based access control and configuration of things with the software. Basically, this product is installed at the client side, so we don't have any control of anything. So everything, the SQL would be installed when you run the application, and we do have a user and password set up everything, but they can change it once the product is installed. So this is a two-tier core data model and the central code repository that I was talking about. And the application-specific extensions are different from that. As I said, we used Entity Framework for our projects. With the property to column mapping and the configuration side, we are using the third type of the code first approach in that. That's the high level. Any questions? I tried to run fast because of the time.
Yeah, that was great content. Any questions for Srikanth?
No?
Okay. All right. Thanks, Srikanth. Appreciate you
Guys.
presenting that for us tonight. That's great. We are running a little bit short on time, so Brian, I hope you don't mind, but I think we're going to cut your presentation out for tonight, and we'll have to learn about WebAssembly when you give the presentation in January. But until then, we still have Ravi to get through. So Ravi's going to talk to us about integration testing in the Web Application Factory, which is kind of a new cool feature in .NET Core 3.
Hi, everyone. Can you guys hear me?
Yep, we can hear you.
Okay. So integration tests are not new. We've all been doing integration tests for a long time now. So this is mainly to show the Web Application Factory, which is part of the Microsoft NuGet package, the MVC.testing NuGet package, which I'm going to show. That's really handy. It cuts the amount of code we write to spin up, to set the configuration of the integration test. So I'm not going to go into like the differences between unit testing and integration testing and the scope of integration testing, since it's a very short presentation. But I'm going to go right into the code. Let me share my screen. Can you guys see my screen?
Yep, I see Visual Studio code, or some code inside of Visual Studio.
Perfect. So I have a simple solution here. I have an API and I have integration tests. So very simple API. Not much happening here. Just the boilerplate that comes out of the Visual Studio template. I just have one single controller. And I didn't modify any existing, but I just added a couple of endpoints down below here. Actually, just one. Load people, and it just returns. I'm not even using iAction result or anything like that. So it's very bare bones API. It returns a collection of people. I think this is already running. There it is. So if I fire up my local host, I just have a JSON array of 3 different people here. So that's it, the scope for the API. And I'm using Entity Framework. If you open my startup file, I have registered the AppDB context to use SQL Server. So it's using SQL Server as a provider for this. And before I talk about the integration test, I just want to quickly show this diagram here. This really helped me understand how the request processing is happening within the ASP.NET Core system. So on the left side here, this is how the request would go through from a real application. And on the right side, how the request will flow through from an integration test perspective. So on the left-hand side here, the request is coming from the browser and over the network, and it hits the Kestrel web server that is offered out of the box from ASP.NET Core. And the Kestrel web server will output the HTTP context, which contains the request and the response, along with a lot of other stuff. And that is passed along to the pipeline. So the dotted box here is the pipeline that is set up for your application. The contrasting to that, on the right-hand side here, when the request is not really coming from the browser, it's an in-memory request. It is generated by the WebApplicationFactory, and that's the core feature of the WebApplicationFactory that I'm going to show. It creates an in-memory request for you, and then it doesn't go through the Kestrel, but it goes through the test server. And test server is also part of that NuGet package, the MVC.testing. And it kind of has a similar functionality that like Kestrel, but it's pretty lightweight, it's fast, and it outputs the HTTP context. And the context goes through the exact same middleware pipeline. Consists of your own middleware, whatever you set up for your app. So that's kind of the high-level understanding of what's happening in an integration test. The 2 main concepts here is it's an in-memory request as opposed to a request over the network, and it's not hitting the actual web server Kestrel, instead it's hitting the test server. Now I'm going to go back to code real quick. So if I look at my dependencies, I'm going to collapse real quick, open integration tests. And if you look at my dependencies, the package that I'm talking about is this one, Microsoft.ASP.NET Core.MVC.testing. This is the only package that I need from the Microsoft testing standpoint that helps me set up integration tests. In the past, in ASP.NET Core 2.x, we needed the test host package. You can still use it. If you want to write that extra lines of code, feel free to use it, but this one covers a lot of that. On top of that, obviously, I'm using XUnit as a testing library, but feel free to use whatever you want to use. I think most libraries have similar constructs about test setup and teardown and stuff like that. So that's just a testing library. So let me jump into the test. So here I have a testing class, right? So this is my test class, and the important thing that I want to talk about is the iClass fixture. iClass fixture is offered from XUnit, and this is a mechanism using anything you put in the iClass fixture is run only once per test class, not test method. Anything you decorate with a fact becomes a test method. But whatever you put in the iClass fixture is shared. It's a shared context between each test within a single test class. So that's that. So what we did here is the number one thing to remember is the startup that I used for the main API is the exact same startup I'm using for my integration test too. Obviously, that's not a requirement. So this is a pluggable type of feature, right? You can create your own configuration and you can inject your own startup for your integration test, but that kind of defeats the purpose, in my opinion, because you want to test a real app as closely as possible. So I kind of shared the same startup. So however I configured my pipeline in my main API is exactly the same way that I'm testing. So let me jump back into that. So this is the Web Application Factory that I'm talking about. So this one is coming from this package up here. But what I did is I created a wrapper on top of it. And the reason for doing that is that I can overwrite a lot of stuff that makes sense for my integration tests. So in this case, I'm overwriting the app settings.json. In my main API, if I open it up, so here I have some settings here, and a good practice is to convert these settings into a strongly typed object. So I do have, I think, app config here. So this basically converts those into a strongly typed object, and .NET Core does this for you. We don't have to do that, right? So in my test class, in my custom web app factory, I use the same strongly typed object, and I can overwrite whatever values that I have in my main app. So this is another nice way to override any settings. And on top of that, what I'm also doing is I am not even using SQL Server. If you remember, in my startup class, I showed this AppDB context registration that is using SQL Server. But over in my integration test, I decided to use SQLite. For SQLite is also a relational database. It's not a full-blown relational database like SQL Server, but that's good enough for my tests. And it's in memory. So the process of spinning up a database and tearing down a database is very fast, as it's all happening in memory. And it helps to run your tests fast. So I decided to use SQLite. Obviously, you don't have to switch the database. You can run end-to-end. All of these are optional. But if you do want to swap an API, a third-party API, and inject a mock API, obviously you can inject the URLs using this config, this type of changes here, and also you can change your database connection strings like this. So the only thing that I'm exposing from the application factory is service provider, right? And the reason I did this is because the service provider, it has access to all the services that are registered with the .NET DI system, right? So if I go back into the startup file here, if I scroll to the configure services method, this is primarily the way we register the app dependencies into the .NET default DI system, right? The iService collection holds all the services together. In this case, I'm using controllers, which is a way of registering the MVC related services. And then this is my strongly typed config object. Here is the SQL Server and a kind of like a data service to access my database objects. So all of these are accessible through the service provider, and I'll show you that in a second. So that's the only property that I exposed from the application factory. Now I'm going to switch over to the actual test. So the important thing about this is looking at the constructor first. So I'm injecting that custom application factory into the constructor of the test. So, and this is what's this single line is responsible for creating your HTTP client. And this is the one we will use to fire all the requests. If you look down below, client.getAsync, and whatever routing system you have, however you configured it, it honors the same routing system. So it's as simple as that. So creating an HTTP client is very simple. And this, as you look in this diagram, this client is not the same as the web client. This is an in-memory client, which has the same features like it, but it's very fast and it doesn't require a network. And obviously you don't have to deploy your API before you start firing your integration tests. So a lot of nice features there. And the service provider, I'm using that here to get an instance of the AppDB context. Now, why do I need the DB context in my tests? Because we want these tests to be autonomous, right? So we want we want each test to be truly isolated from the other tests. So I want to spin up my own database in each test. And at the end, I want to delete the database. I want to close the connection. So I'm completely done with that database. So there is no shared context between each of these tests. So when I create another test, I'm going to open the connection again. So I'm using that DB context, the underlying database. Now this will be SQLite instead of SQL Server, because in the factory, in the web application factory, I registered a SQLite. So in your test, whatever you put it there, it'll open the connection and it'll ensure the database is created. And here I'm just adding 3 records into, this is the straight EF core, right? There's nothing complex here. You add it to a table, I'm not tracking, and then call save changes that persist the thing into the database. And this is all in memory. And then I use the in-memory HTTP client to call that endpoint and ensure status code. I run all my asserts. And at the end, I deleted the database. So pretty simple. It is very straightforward. You're fighting the real endpoint here using the real routing system, however you configure the routes. If I look at my controller, so this is the same route that I gave here, right? So it's people, so all I can do, I can come back here and just say /people. It just takes care of that. So it looks like you're calling the real endpoint. This is the syntax looks like you're actually calling it over the network, but it is not. It kind of follows this diagram here, and the test server is completely abstracted away. I don't have the code to show you the older version. In the older version, you actually have to use a using block, and you have to create a web host. If you look at the program.cs here, here we use a default web host, right? And then we say, hey, use startup. And all of this is duplicated in your integration test setup. And the setup looked kind of heavy because we have to write all these statements, and we have to use the using statement and close it and open the test server. A lot of that got really simpler. I thought this is a nice and easy way to get started on the integration test. This is available .NET Core, ASP.NET Core 3.x, the NuGet package. And so it's really handy and a neat way of getting up to speed on integration tests. That's pretty much all I have for this. Let me know if there are any questions. Okay, I'll stop sharing.
Fantastic.